Hello, myself Smrutirekha Sahoo. I work as power traction design engineer at Alstom. As traction design engineer, we do simulation test on the test bench and where we try to emulate driving conditions for real-time train operation. In the control system, we have several components which includes inverter, the motor and also a controller. What we try to do is to emulate the driving condition and check the performance in different parts of the drive system, out of which the machine is more sensitive to the overstress, and we try to check the temperature at the machine so that we operate it in optimized way with respect to the thermal limits it has. So what the controller expects, the temperature measurements in different parts of the machine to take into consideration of the signals it sends to the machine to operate in a defined torque and speed. In order to do that, the controller should have the knowledge about the temperature at different parts. The accurate way of doing temperature estimation is to use high fidelity model, but in controller system, it cannot be accommodated. So the controller has a reduced order model which estimates the temperature. Since it is a reduced order model, all the parameters in the model cannot be estimated analytically. So the usual way of doing it is empirically based approaches where measurement data is taken to calibrate the thermal parameters. This kind of operation takes a lot of supervised hours from the test engineers. Instead of doing that, we propose to use AI machine learning method to improvise the efficiency. On top of this, finding these parameters are very sensitive to the different operating conditions, also the environmental conditions which the machine operates. So the reinforcement learning as a solution is proposed to this kind of problem. Why reinforcement learning? Because it has the capacity of learning itself by interacting with the environment the machine operates. Reinforcement learning works forward in time, learning in a trial and error basis from the past experience, and try to do the action and the state improved based on these learnings. As a solution, we propose like a multi-agent system reinforcement learning framework with transfer learning usage. The transfer learning usage enables the learning from the individual reinforcement learning agents to utilize the domain knowledge and predict the temperature based on the learned knowledge. As a multi-agent system, there is a set of reinforcement learning agents which are TD3, soft actor critic, and also deep deterministic policy gradient. These reinforcement learning agents, they have their own advantages of predicting the temperatures depending on the type of driving cycle and the variability in the driving cycle operations. They are particularly useful in an environment of multi-agent system because they learn from each other and try to do their actions better by learning from each other. As transformer learning system, we could learn from the previous learnings and predict more efficiently without going for detailed training. By synergizing transfer learning, one can avoid pre-training on the data. For doing the training, synthesis data for 9 drive cycles has been used, and based on the pre-trained models, transfer learning has been utilized to predict the data for the measurement setup, and this has improved the efficiency of predicting the temperature better by fine-tuning these models.